Okay, number 5 to take us to the home stretch here. Chapter 8, Hypothesis Testing. Hypothesis testing is the formal approach of collecting data and figuring out, do you have a statistically significant effect? We used to have to do all this out by hand. Hypothesis testing was the way we did it. Now we have computers to do all of this for us. And so we can do that, but I want to take you in this chapter through the steps of hypothesis testing so you can understand the approach, and then I'll get you to do a sample problem here. So if we do hypothesis testing, we're going to go back to the blueberry situation. Page 233, a hypothesis test is a way to use sample data to evaluate a hypothesis. Do the blueberries work? So the first thing we have to do is we have to go back to the blueberry situation, and we have to state what we call a null and alternative hypothesis. Turn to page 236. The null hypothesis is basically saying that nothing happened. And so we have an HO, and the HO, mu or U there, that when people got the supplement, that mu equals 80. So the idea would be, if we collect data and we don't find that there's any effect, we have to be supportive of the null hypothesis. The alternative hypothesis is that when people get the blueberries, mu does not equal 80. So obviously we're hoping that things help the people out, but we have the null and alternative hypothesis written in Greek letters because it's all Greek to me. So step 1 is you state the hypothesis. You hope the blueberries help. Step number 2 for hypothesis testing. You have to set the criteria for determining if something is significant. This is going to be a bit of a story, but it's just going to be kind of a hard and fast rule at the end. We have to decide on making a decision here. If you turn your books to page 238 and 239, we have to pick a critical score. And the idea is this critical score will be the score that if we get above that score, remember we did that with the chi-square, we're going to say we have a significant result. If you look in figure 8.5, the critical score we almost always select is the score that separates the upper and lower 5% of the distribution. That if you look in figure 8.5, if we decide our alpha level is 0.05 two-tailed, that means that we're only going to reject a score and say the blueberries really work if we get a score really, really high, above a 1.96. So the critical score is almost always with the z-test, 0.05 with two tails, and that z-score is either plus 1.96 or negative 1.96. We hope that after we collect the information on the blueberries that we get a z-score way above 196, and then we can say the blueberries really worked. There's more to it than that. If you want to read through the book, you certainly can, but if you want to just take this hard and fast rule, that would be fine as well. So 1.96 is the way. Step number 3 is to do the computation. So I think the book does some of this for you. It looks like on 241 it does it for you. The z-score formula on 241, they use an M instead of what I use, which is the X bar here. The z-score formula in the numerator, remember when the people had the blueberries, they scored at a 92. The mean was 80. So the numerator is a 12. Do you remember what we call the numerator? The numerator is called the treatment effect, and we want the treatment effect to be large. So we get that. The denominator, we have to compute the darn denominator here. That's sigma over the square root of n. So sigma here, I think, was the value of, we had 20 people in here. Sorry, we had a sigma of 20. The sample size was 25. If you put 20 over the square root of 25, you get a sigma, a standard error of the mean of 4. Do you remember what you want that number to be, large or small? Anything that says error in it, you want to be small. So the denominator is 4, the numerator is 12. That gives us a z-score of 3. And so the idea there, you get a z-score of 3. Is that above the 1.96? The answer is yes, it is. So in this case, we could reject the null hypothesis, and we can say in the real world that the blueberries significantly helped cognitive performance. So hopefully this example makes good sense to you. I'm covering a lot here. What I would like you to do for your homework situation is either try it with an x-bar of 84 and an n of 16 and see if you can do that particular computation. Thanks everybody. I appreciate your patience and hope that you can read through this and figure it out, take some good notes, and send me drafts and make this happen. Bye-bye.